So, hi Bonnie and the rest of the cosmic fishes. I am well on my way of trying to create a scale model of microtubular, and I figured I'm going to use one kind of bead because I'm not as fancy as the microscale where they are using two types of protein for this, but I will make them distinct, the two rows that I've got one already here which is connected lengthwise, which is the black, and that would be the alpha or beta or whatever tubulin, and the other one will be the other, so I'm going to connect those up next with a white thread. But note that between them the wave is a beige or whatever thread, and the way that it's connected right now is quite curious, right? Because it's got a sort of stability to it, and it can, twist and get into curves still. And I could, for instance, roll this up much like what the microtubula do, but I'm gonna not do it like this. I will actually roll them perpendicularly so that it's like a there's the double membrane going on. So the plan is I will connect these up this way, and what I could see with some just glances at the diagrams that people have on microtubuli, tubular microtubes, is that they seem to have a sequence around like this, where it is 1,001 proteins around, which is fascinating, right? Because 1,001 is really a dozen and 1 is 0. So if we're not counting the proteins, the polymers, is it? Which would be the individual beads. If we count 1,001 of those, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 1,001, then between this number of beads there is 1,000 steps. So if this is the number where it turns back up on itself, then while the count of the proteins that they're counting is 13, is 1,001. Note that the count of the steps between them is 1,000. I think that's important to point out. That's the same sort of feature that makes that people make use of with the knotted cord, where it's 1,001 knots. So if we bring the last and the first together, we get 1,000, which is then used for calculations and getting shapes and stuff. Yeah. Anything else? No. I was just too amazed by the way that this moves and shapes for it to just pass by and move on into the realm of tying these things, tethering them together more definitely and decisively, right? So before I finish this entire thing as just the microtubulums, I'm just enjoying all the things that are now possible in between that will not be possible once it's got its structure. But I do think that there's a good chance that there is similarities between these behaviors here and what happens in the actual organic case of our cellular life. Yeah, I will keep you updated on this. Take care. Camera's there. Keep looking in the wrong corner. Okay, now another look at it after completion. I think it's quite nice. Takes a lot of time, a lot of pieces, even to get this far. And I have differentiated the alpha and beta tubulin, or whatever it's called, the two proteins, with black and white string respectively in the spiral that goes around, and then took the beige kind of brown string to weave the two lines together triangularly. Now it's clear, looking at this, that I could have gone other ways around this also, of course. There's like these directions here that I could have gone. Maybe those are the ones that these two-legged overhand proteins run along. Or maybe they actually run along triangles in here. Or the proteins like that, possibly. Beautiful. And I think it would also be interesting to have made this not with complete triangulation, but for instance, I could have, one possibility could have been that if I took the black string, I could also not only go around this line but jump over to this one, but only in one direction, and jump back, right, so that there's only one direction of connection in black between the two lines, and then have the other be white. That would be another kind of nice pattern, where the triangles themselves these would be black and white, changing one to the next. But also I think it would have been interesting to not completely triangulate between the two lines, but only put in one direction in total, so that it would be basically wait, where is it? Here. This kind of situation, right? So the overall weave of the entire thing could be turned from one direction to the other, and in general the entire membrane would be a lot more malleable in this way. Could also stretch and shrink, but if it stretches, it shrinks perpendicularly, I mean precessionally, and vice versa. If I squish it this way, it expands precessionally. So that would be interesting to see in a spiral like this. But I'm quite happy with having done this one, because it kind of felt like being more reasonable to begin with, to just have the proper thing. Oh. Nice. And as I said before, with respect to the amount of beads or proteins that go in a circle before the spiral closes in on itself. Let's see, if we count the beads here, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, a dozen, and a dozen and one. That's the one where it connects to with the next layer. A dozen one, right? So that's the beads, but if we count the steps between them, then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, a dozen. And I think that's actually pretty neat that on this level of our intracellular organisms, where we have these microtubular, that there is such a dozenal resonance there. I mean, it's not the only place after all, but it's a another good place to look for it. Lots of dozens to go around. Yeah. Nice. I don't know, it kind of reminds me of a cylindrical slide rule. Fuller calculator. Well, so long. Take care.